Physics Part 167. The wire is connected across the terminals of a battery of EMF 1.5V and internal resistance 0.40 ohmega. A. Calculate the potential difference across the wire and the power dissipated in it. B. In an experiment, the length of this wire connected across the terminals of the battery is gradually reduced. Sketch a graph to show how the power dissipated in the wire varies with the connected length. Number 2. Calculate the length of the wire when the power dissipated in the wire is a maximum. Calculate the maximum power dissipated in the wire. Number 3. Calculate the maximum power dissipated in the wire. Number 7. From power stations, electrical energy is transmitted over long distances to homes, businesses. At 400 kilowatt, an alternative might be to transmit the domestic supply voltage of 230 volt. Explain how the right voltage option reduces the power losses in the cable. A small laboratory, question number 8. A small laboratory water heater is connected to 240 voltage AC current. AC circuit. Supply the heater as resistance of 40 ohmega. Calculate the average power used. Calculate the maximum instantaneous power used. Calculate the minimum instantaneous power used. Calculate them accordingly. Sketch a labeled graph to show at which point in the cycle of alternating current the maximum and minimum instantaneous power is used. Next, we've got a very interesting topic, and it is waves. Chapter number 8, waves. The aim of this chapter is to introduce some general properties of waves. We shall meet two broad classification of waves, the transverse waves and longitudinal waves, based on the direction in which the particles vibrate relative to the direction in which the wave transmits energy. We shall define terms such as amplitude, wavelength, frequency for a wave, and derive the relationship between speed, frequency, and wavelength. We shall look at demonstrations of some properties of waves, and such as reflection. We should look at demonstrations of some properties of waves, such as reflection, refraction, diffraction, and interference. In connection with the interference, we shall use the principle of superposition, which tells us how the waves which come together at the same place interact. The transverse waves and longitudinal waves. At the end of our first section, you should be able to show an understanding that energy is transferred due to a progressive wave. You should be able to compare transverse and longitudinal waves. You should be able to describe what is being meant by wave motion as illustrated by vibrations in ropes, spring, and ripple tanks. You should be able to show an understanding and use the terms displacement, amplitude, phase difference, period, frequency, wavelength, and speed. You should be able to analyze and interpret graphical representations of transverse waves and longitudinal waves. You should be able to recall and use the relationship intensity is proportional to the amplitude. You should be able to deduce from the definitions of speed, frequency, and wavelength the equation V is equal to Fa. You should be able to recall and use the equation V is equal to FA.